everyone. In today's video, we are going to cover reflections. Our learning targets for today are I can identify a reflection, I can find the coordinates of a figure reflected in an axis, and I can use coordinates to reflect a figure in the x or y axis. So a reflection is what we call a flip over a line called the line of reflection. Now when I make reflections, each point and its image are the exact same distance from the line of reflection. And a reflection is also an example of a rigid motion. Now we have two common lines of reflection. Our first common line is the x-axis, which remember the x-axis is my horizontal axis here, which again remember is my vertical axis here. Now I can also reflect across vertical and horizontal lines. So x equals a number would be my vertical line, and then y equals a number would be my horizontal line. I can also reflect over diagonal lines, which would be y equals x or y equals negative x. So let's look at a few reflections over the x and y axes. So my first example here, I have triangle ABC with vertices, and I want to reflect over the x-axis. So if I look, the x-axis is this axis here. So I want to reflect over that line. So essentially, imagine if I was folding my triangle ABC into quadrant 3 and quadrant 4. So now what I want to do is count the number of spaces from each point of triangle ABC, my pre-image, from the line of reflection, and then move that down. So C is only one space away, so C prime would be here, because that's one space away from my line of reflection. Now B is 7 spaces away, so I would count 7 spaces from my line of reflection down. So that would be here. And this will be B prime. And then A is 2 spaces away from my line of reflection, so 2 spaces away would be here, and that's A prime. And now here is my image, triangle A prime, B prime, C prime. Now I can list my coordinates. My coordinates would be A prime of -4, -2, B prime of 4, -7, and C prime of 5, -1. Looking at number 2, I have the rectangle PQRS with the following vertices. I want to reflect over the y-axis. So again, the y-axis is this axis here. So I'm going to reflect over this line into quadrants 2 and 3. Again, I want to count the spaces from my line of reflection, and then I would move them to the left. So if my P coordinate is 1 space away, I'm going to be 1 space away from my line of reflection right here, and this will be P prime. Q prime would be 2 spaces from my line of reflection because Q is 2 away from my line of reflection, so that would be right here. So that's Q prime. R is 8 spaces away from my line of reflection, so that's going to be 8 spaces away here, and this will be R prime. And then S is 7 spaces away from my line of reflection, so I'll count 7 spaces, and this is S prime. So now this is my image, which is rectangle P prime, Q prime, R prime, and S prime. Now if I list these coordinates, P prime would be -1, 2. R prime is -8, 3. Q prime is -2, 5. And S prime is -7, 0. Now notice from these coordinates, they are the same coordinates as my original pre-image. However, either the x coordinate or the y coordinate became the opposite. So when I make reflections over the x and y axes, I also have rules for them that I can follow. So if I want to reflect across the x-axis, I can follow this simple rule. So I have my original x, y coordinates. They will change to the y being the opposite value of whatever the coordinate is. So if the y is positive, it will change to negative. And if the y is negative, it will change to positive. And likewise, the y-axis is the opposite of x comma opposite y. That will be opposite x comma y. So if I have my original coordinates x, y, this will change to opposite x comma y. So notice my x-axis, when I reflect it over the x-axis, I change the y-coordinate, and the y-axis, I change the x-coordinate. Now applying these rules, if I want to flip across the y-axis, for example 3, the y-axis had the rule opposite x comma y. So if I change every x value here to be the opposite, I can just plot those points. So if I notice f is -5, -2, well, the opposite of -5 is +5. So f prime's coordinates should be 5, -2. So if I plot 5, -2, it'd be right here, which is f prime. And I can count that many spaces from my line of reflection, and it would be the same thing. Now if I look at g prime, well, g is -2, -2, so g prime would be 2, -2, which would be right here, which is g prime. H is 0, -6, so h prime would be 0, -6, because 0 is not positive nor negative, so I can't have an opposite of 0. And then I prime, I is -8, -6, so I prime would be 8, -6. So that coordinate would be right here, and this is I prime. Now, drawing in my trapezoid, I have trapezoid F prime, G prime, H prime, I prime. Looking at number 4, I want to reflect across the x-axis. So again, if I reflect across the x-axis, my y-coordinate will be the opposite. So I'll have the rule x opposite y. So if I look at W, W is -2, -4. So if I change the y to be opposite, W prime should be -2, +4. And then x would be 1, comma, +2. Y prime would be 4, +4. And z prime would be 1, +6. So drawing in these coordinates, I would have the following image of rhombus W prime, X prime, Y prime, Z prime. Now if I want to reflect over other vertical lines and horizontal lines, I can reflect over X equals a number and Y equals a number. So looking at number 5, I have X equals 4. So remember, if I have X equals a number, that's a vertical line. So x equals 4 is going to be a vertical line at 4. So if I draw in this vertical line at 4, this is my line of reflection here. So I'm going to count the spaces away from my line that my pre-image is and count to the other side of my line. So L is 1 space away, so L prime would be here. J is 3 spaces away, so J prime would be here. And K is 2 spaces away, so K prime would be here. Listing these coordinates, I'd have J prime of 7, -1, L prime of 5, -2, and K prime of 6, 3. Now if I want to reflect over the Y equals a number, remember Y equals a number will be a horizontal line. So if I have Y equals 2, for example, number 7, that's going to be this horizontal line at Y equals 2. So again, I'll just count the spaces away from my line of reflection that my pre-image is, and then reflect over that line. So E is 1 space away, so I would have E prime here. F is 5 spaces away, so I'd have F prime here. D is 2 spaces away, so I'd have D prime here. And C is 6 spaces away, so I'd have C prime here. And then listing my coordinates, I'd have C prime of -4, 8, E prime of 6, 3, D prime of -2, 4, and F prime of 4, 7. So now if I want to identify my line of reflection, I want to look for the line of reflection that is in the middle of my two figures. So I'm looking for the midpoint of two of my points, 1 point from the pre-image and 1 point from the image. So if I look at J and J prime, notice how they're 4 spaces away here. So my middle point would have to be 2 spaces away right here. So that's my line of reflection, which if I draw a straight line, this is the y-axis. So my line of reflection here is the y-axis. Now looking at this example, again, if I look for the midpoint of two of my points, let's say I have z and z prime. Notice z and z prime are 6 spaces away. So my midpoint would be 3. Now this was a horizontal line. So that horizontal line is at 1. Remember, horizontal lines are y equals. So my line of reflection is y equals 1.